Welcome to the video on the box and whisker plots. There are videos associated with specific calculators on how to create the box and whisker plots using the specific graphing calculators, whether it's the Texas Instruments, GeoGebra, or Casio, on Brightspace, and also in this YouTube content. Feel free to watch those if you want some more specifics on how to do the actual calculations. I'm just going to go over a brief overview of box and whisker plots with this. Box and whisker plots are a summary of the quartiles and smallest or largest data values. The example says determine the 5-number summary for the following distribution, and then they give us a list of raw data values. These raw data values do look like they are listed in ascending order. First thing we would need to do is arrange them in order. We've already have that done for us, and then we will find the median. There's another video in my channel and on Brightspace that shows how to find that, so I'm going to forget that for right now. The median again is the 50th percentile or the second quartile. Now, after we find the median, we can split the distribution into two different halves. We can talk about the upper half and the lower half. If we find the median of each of those halves, they will tell us the first and third quartiles. This, along with the least data value and the greatest data value, will be our 5-number summary. Again, we have videos on the feed that will show how to do all of those calculations. Now, in order to create a box and whisker plot, or in order to read a box and whisker plot, all we need to do is understand that each of these vertical lines on our box and whisker plot, which I'm highlighting in red, represent one of the 5-number summaries. So this value here would be the least value or the smallest data value. This value here would be the first quartile. This value here would be the second quartile, or the median. This value here would be the third quartile, and this value would be the max, or the largest data value. We would connect the middle 3 lines with a box, hence why it's called a box and whisker. This middle box here represents the middle 50% of the data values. Because each of these values that are identified on the graph represents approximately 25% of the distribution. So each little section of this box and whisker plot represents about 25% of the data values. From here to here is about 25% of the data values, and then between Q3 and the max we also have 25% of the data values. We also have a definition now we need to talk about, which is called the interquartile range. The interquartile range is the middle 50% of the data values. It is found by subtracting the third quartile minus the first quartile, and that will give us the interquartile range. So on the previous example, the IQR, the interquartile range, would be where the middle 50% are. Middle 50% of the data are, and in that case they would be between 2, which is Q1, and 9, which is Q3. So the IQR, the interquartile range, is 7. 9 minus 2 is 7. Now we can use the interquartile range to determine whether or not our data set has outliers. We can now define an outlier to be any value that is more than 1.5 times the length of the interquartile range from the mean. If we have that, then we can consider these data values potential outliers.